And we are back this week for our number 33 of the Everyone Can Contribute Cafe. And today it is my pleasure to welcome Matt from Snyk. So we are talking about security, we are talking about cloud native, we are talking about Kubernetes, all the magic things which we've learned in the past few weeks. And I'm honest, I know about Snyk a little, but I haven't tried it myself. And I'm totally looking forward into joining the conversation, seeing a little bit of an introduction, what it can do, how it integrates, and so on. So without further ado, I would just say, hi, Matt, kick us off. Let's do some magic.
Thank you for that intro, Michael. I'm not sure it'll be magic, but we'll see. So I guess I'm trying to avoid, as most of us in developer advocacy do, we spend our lives giving slide decks, and I'd much rather kind of have a conversation about this stuff than bombard folks with slides. But I guess the starting point for me really is like, you know, why is security different in the cloud native world, right? And I think this explains in a sense why we need a new focus on how we do security. You know, I've got plenty of gray hair. You know, I've been around the computing industry for a pretty long time, and you know, when I started, it was all actual hardware, right, and big machines and all the rest of it, and you know, you kind of didn't change much. You know, that was the aim of corporate IT type environments, was never change anything unless you absolutely have to. And you know, we're in a very different space now where we want to change all the time. And when we combine that idea, this change all the time, like continuous delivery, continuous integration, and we combine that with what are developers responsible for now as opposed to, let's say, 10 years ago? You know, and I think, I mean, maybe I will just stick one quick slide up here, because I think this is a kind of useful picture. Let's just do this. It's over here. Where are we? Bear with me 1 second. So if we look at this, you folks hopefully are seeing that slide there, right? So, you know, yeah, for those of us who've been around for a long time, and I'm sure this will be familiar to quite a few people on this call. You know, the piece that developers were responsible for was really just this tiny bit at the top. And the rest of it, you know, virtual machines or the hardware, the networking, you know, all of that stuff was kind of in somebody else's domain. You know, you had specialist teams who just did that. And, you know, so the implementation of security in that world was like, well, for a start, we don't change very often. And secondly, that means that we're just going to do security right at the end. So, you know, our developer develops it, they ask for a storage LUN from the storage guy, they ask for like a network connection, they ask for a virtual machine, and this whole process takes months. And so right at the end, you know, the security team are like, right now we're going to check it all. And, you know, it's kind of worked okay. But, you know, this world that we've moved into now is that our infrastructure and our workload, our application, are almost completely tied together, right? So if we consider how much of our production workloads now are deployed in containers, you know, we just did a survey at Snyk over the last 3-4 months, and you know, even in big enterprises now, you know, people were talking about having 50-60% of their production workloads in containers. And you know, how do you separate out the application from the container, right? From the container image. And lots of times it's not just the container image, it's the Kubernetes configuration that makes that all work. And in lots of organizations, this might be the same team developing this stuff. So now we've gone from this place where we had the developers just responsible for this small bit at the top to the developers now responsible for almost all of the stack. And, you know, that's a much bigger kind of responsibility space for developers to have to think about. You know, on the one hand, we've got this big pressure to deliver much faster, you know, keep our deployment velocity, which is really what differentiates successful businesses in cloud, right? Is how fast can you deploy software? Because that's what it comes down to about businesses who are successful, that really rapid iteration. So developers have got that kind of pressure on them, and now they own, you know, almost by accident, in a sense, most of the stack, because they're responsible for this piece that effectively defines the compute infrastructure and the configuration for that compute infrastructure. And so, you know, it's kind of becomes the much more the developer problem about you know, security issues, because now that's all under their purview. You know, they've got the container image, they've got their own application code, and the application itself has, you know, perhaps we're pulling in third-party open source dependencies. And, you know, these responsibilities have all kind of ended up with developers. And that means that we kind of can't think about security in the same way that we used to, because we need to be able to keep up that deployment velocity. And so, you know, that presents kind of a lot of unique challenges, I think, for security in the cloud native space that wasn't there 5 or 10 years ago. And this is why we're seeing a lot of new approaches to how we do security in the cloud native space. And this is where this idea of Devsecops that lots of people talk about kind of comes into play, where, you know, like we merge development and operations in order to, you know, to give us those ways of working to rapidly deploy applications. That what kind of now needs to happen is that you merge that security into that development workflow as well. And there's lots of, you know, there's lots of terminology around this. People talk about shifting left, right? Which is basically like, you know, where do we need to think about security in our development workflow? And, you know, our belief at Snyk is that we really need to build that in all the way through the pipeline. So, you know, at every stage that we're automating in our CI/CD, we need to be able to put security checks in there, and also to make it super easy for developers to use those tools. Right? We don't, you know, there's no way that our developers are going to become security experts. So if you present developers with like a huge list of CVEs, you know, the people are just going to sit there and go, well, what am I supposed to do with this, right? So it's got to be about presenting the information in the right way that developers can consume it, and also providing them actionable ways of moving forward and dealing with those issues. And at Snyk, we kind of focus on I guess four key areas. Used to be 3, but now 4. You know, the first area is open source packages, right? I mean, you know, you look at the patterns of how applications are developed now. You know, your typical application has a really small amount of homegrown code and then a ton of open source packages in it. And you know, that might be Node, it could be Go, it could be Python, it could be whatever, right? But that's how we write applications these days. And so you've got this big chunk of code that's kind of outside of your responsibility. You know, you're not maintaining it. How are you supposed to know what version to use, whether it's got vulnerabilities in it? So that's the first thing. The second thing is around container images and looking at vulnerabilities in container images. And then the 2 kind of most recent ones are infrastructure as code, and by infrastructure as code we include Kubernetes YAML, we include Terraform, all those kind of that stuff that creates our things, Helm charts and all that stuff. And then we've just launched a static application security testing feature as well, called Snyk, which is about testing your homegrown code for actual coding mistakes, whether that might be unsanitized inputs or whatever. That's going to pick those things out. So let me just show you what that looks like. So hopefully this is the one I want. Where are we? So no, I don't want that. Stop sharing that. I want this. Okay, you folks all seeing my browser here. So this is the Snyk dashboard, the kind of high level view of what's going on in my Snyk account. This kind of first page really just gives me an overview of all the things that are going on across all the projects that I've imported into my Snyk account. And if we go to projects, it's probably an interesting place to start. There are a bunch of different ways that we can interact with code. We can integrate with a whole bunch of source code management stuff and with CI/CD tools, and I'll show you the CLI and things like that in a minute. But this is probably the place that most people are going to interact with their source code. And we've got I've connected my Snyk to my GitHub repository, and so it's going to read in all the repos that I have there, and I can just click things and import them straight into my Snyk account. If we look at the set of integrations that we can kind of work with, GitLab, obviously, Bitbucket, most of the container registries that are out there. Kubernetes, I'll talk about in a second. Loads of CI stuff, and then we'll also look at some of the IDE plugins. But once we've got our code in there, Snyk's going to start scanning that for a first scan, and then it's going to scan it on an ongoing basis. So if we take a look at one of these projects, Snyk has looked in that repository and found a bunch of stuff that's interesting to it. We talked about the open source packages. So this is a Node application. It's deliberately vulnerable. It's got loads of vulnerabilities in it, in fact. And the way that Snyk works with most of the language support that is via the package manager. So it's going to look at what's been defined in that file. It might be requirements.txt for Python. In Node's case, it's the package.json, and it's found a whole bunch of issues of vulnerable dependencies that we're bringing into this application. But the important thing to think about when we think about dependencies is that we are declaring dependencies in our applications, but those dependencies have dependencies, right? And sometimes that dependency tree can be gigantic. I mean, anybody who's ever done anything with Node, and I'm not a Node programmer, but Node can end up bringing in just millions of packages. And what Snyk does is build the whole dependency tree. So for everything that's been defined, it's going to go and look at what each of those packages that are being brought in there. And so looking at dependency at vulnerabilities all the way down down that tree. And you can see, we found a whole bunch of various severity kind of vulnerabilities in those packages. This is a fairly common one, this Dust.js one. It's high severity. And we're going to provide in-depth information about each of the vulnerabilities that have been found in that code code base. And this isn't just based around, you know, one of the issues around vulnerabilities is always, how do I prioritize what I fix, right? Because we can't fix everything. You know, no software has 0 vulnerabilities unless it's like, you know, something that's very small, and you know, some things may not be appropriate for your environment or whatever. So what we build is a whole set of scoring that's based not just on the CVSS score, which is the standard for vulnerability scoring, but it's also on things like, is there a mature exploit for that particular thing? And you know, the thing that's going to push it up to highest priority is there a fix? Because you know, in some ways it's a no-brainer to say, well, if there's something that I can get a fix out of just by upgrading a package, then I should fix it, right? Because there's nothing that's stopping me from doing that. So there's a whole bunch of filtering here, as you would expect. You know, you might want to filter out things where there are no fixes available. You know, sometimes people are interested in that, but, you know, often it's like, well, there's no action that I can take from that. And, you know, as I said earlier, what Snyk is really about is about action for developers to be able to action things. It's not, it's the key point of it is we want people to be able to fix things and not have to really dig down very deeply into what each of these things are doing. So one of the other things that I can do from here is actually just raise PRs directly against this repo in GitHub. And I can do that automated on an automated basis, where I can just say, well, any fixed PR, anything that is fixable, make a fixed PR. In a lot of cases, these fixed PRs will just be a you know, upgrade the package version in the package management. Sometimes we'll actually provide patches for a particular application if that's a serious issue that there isn't a fixed PR for yet. And you can see, you know, this is going to if we look at what's changed here, we can see it's just bumped the version of that ADM zip to 0.4.11. So what else can we look at here? So that's a kind of, you know, the very quick look at the open source packages thing, and that'll work in a very similar way whether we were looking at a Python repository or a Java repository or, you know, any of the languages that Snyk supports. But we'll have found a bunch of other stuff in this repository as well. Obviously, there's some Kubernetes manifests in here, and we've also scanned those Kubernetes manifests for obvious security issues. So here we're going to be looking at, you know, do we have resource limits set? Do we have the correct security context settings set? And just providing that information to the developer about what things they may want to change in that stuff. And then there is a Dockerfile here, so we'll have tested the Dockerfile as well. And based on what was in the Dockerfile, this I think is based on Node 6, so it's got very old Node version. It's got a lot of vulnerabilities in the base image, which I've got a feeling is based on Debian from what I remember. But what we do when we get provided with the Dockerfile is actually go and look in our database about what other base image recommendations may help to reduce the vulnerability count if you were to switch your base image from that base image with a very high vulnerability count. You know, most vulnerabilities in container images are in the base image that's been imported into that Dockerfile. So, you know, by upgrading your base image, you're likely to immediately solve a lot of the problems. I think some people, when they first come to looking at container image security, they kind of like, oh, I'm going to need to start like upgrading individual packages in that base image, and that's really not the way you want to do this. You need to fix things upstream that are coming to you downstream, and you sort of do have to at some point trust that upstream provider who you're using in your Dockerfile in that from statement. It's very easy to suddenly become the maintainer of your entire base image, which no one really wants in the container world, because that's just not a good use of your time. You're much better off saying, I'm going to trust, whether that's a Debian image or a particular packaged image. We could talk a lot more about the kind of slim distroless Scratch, all that kind of stuff, but there probably isn't time today. But perhaps we can talk about that a bit later. And then the final thing that we've picked up in here is is analyzing the homegrown code that was in here. So this is code that didn't come from an open source package, and Snyk code has actually analyzed what security issues there are within the code itself. And what's cool about Snyk code is that it's basically like a machine learning framework, and it's super fast. So it's now, I don't know whether anybody's used a lot of these SaaS tools in the past. Certainly when I was in development, they took a very long time to run, especially if you run them over big code bases. Snyk code is now fast enough where you can use it in an IDE, and I'll show you in a second that actually running inside VSCode in a plugin. Just before we move on to the CLI stuff, we can just see. Let's add a project for a container project from Docker Hub, just to show you how that part of it works. So again, I've connected my Snyk account to my Docker Hub account, and now I can see all of the container images that I have in Docker Hub. And to import any of those is as simple as just clicking the button there, and they'll start being scanned on a regular basis in Snyk. And you see very similar things to what we saw when we looked at the Dockerfile, although this is most powerful when we combine the container image itself with the Dockerfile, because that's
Is it me or is it Matt?
No, I think it's Matt. Which also, yeah, Matt is probably have some internet problems, but he's moving. I can see that his eyes is moving. But now he seems stuck again.
Am I back?
Yeah, you're back.
I think the internet broke again. Where did you lose me?
I think you need to repeat the last minute or so. The introduction into like, I want to showcase you how it works live. It's a machine learning framework and Snyk code, and then you were jumping off into.
Okay, cool. Yeah. Right. So let's look at so what we're just the one piece there was just going to touch on before we move on to looking at that in VSCode was container image imported from the container registry will still pick up all of the problems that are in the base image. But when it becomes really powerful is when you link that to the Dockerfile. So we can, as you can see, this one's suggesting to me that I go into the settings and point to the Dockerfile in my Git repo so that it kind of connects the two things together. And that's when we start to be able to suggest alternative base images for you to use. Right, let's go and just keep an eye on time here. Let's go and have a quick look at VS Code. and you can see some of this stuff running in the IDE. Because the first point of call for all of this stuff, where it's the easiest place to fix it, is right at developer eyeballs, right? So IDEs and CLIs, to give developers that insight and the ability to action security stuff right in your code before it's even checked in, is really the most most cost-effective way of dealing with security vulnerabilities, because you're not having to fix things upstream in the pipeline. So if we go and look at, let's look at this one. So this is the code for that vulnerable node application. I've actually got two Snyk plugins running here. One's called VulnCost, and the other one's the Snyk vulnerability scanner. And if we just look at the packages to start with, this is the VulnCost plugin. You can see that it's picking out straight away as soon as I if I was to add to this package.json, i.e. to include another package, it's going to scan that straight away. So it's already telling me that there are, in this particular package, there's one high and 3 medium vulnerabilities, and I can just click on quick fix here, and that's going to tell me what I need to do to fix it. Is just to upgrade, to change that 1.0.0 to 3.1.6, and that's going to fix all of those vulnerabilities that are in that particular package. So you've got that actionable information right in the terminal. And you can also actually go through and look at this, where are we? Let's just click on that. I can find lots of information about what that particular problem is, and I've got the links to the actual vulnerability in Snyk's vulnerability database right in my IDE. So I don't need to move outside of anything; it's just happening right there in my IDE. And then what's also happened here is, because I've got the Snyk plugin running here, is that my code's been scanned for programming issues, and we can see there's a bunch of things that have appeared down here which are showing me issues in my own code that need to be fixed. And what's cool about this is not just saying this is a particular a problem of this particular type, it's also actually showing me the problem flow through that particular function. So, from unsanitized input in the HTTP request body, I'm able to go right through that function, showing where it's flowing into find. And then if I click on it over here, I not only get full kind of details about what's happened in that particular piece of code, but I also get these examples from other open source projects about how other people have fixed it. So it really shows you straight away, like, here's what the problem is, and here's how to fix it. So, here I've got 3 open source projects that have been indexed as part of the Snyk back end, and it's going to give me examples of exactly fixing that exact kind of a problem. So that's the IDE stuff, which is all super cool, right where you need it in terms of developers. And let's take a quick look at the CLI as well. Where are we? Where's my terminal gone? Too many windows. Yeah, let's get that one. No. Just want to share that terminal. Okay. So, and I can do all of this stuff straight from the CLI as well. So this is the repository. Check out the repository with the Kubernetes and Terraform in it, and I could just do Snyk IAC test, and that's going to test all of the files it finds in that repository that are either Terraform, Kubernetes, whatever, and it's going to report to me all of those things that we saw in the UI about, you know, what's wrong with those particular Kubernetes configurations from a security perspective. And if I go into that node application again, I can do Snyk test, which is going to test those open source package dependencies. And you can see all that same information. It's obviously not quite as nicely formatted as it is in the UI. But what's nice is you can use the Snyk wizard, which will kind of do the same. There's the same idea as behind the automated fix PRs, in that it makes it super easy to fix it. So the Snyk wizard's going to do make those suggestions to you about which files should be updated and to which package versions. And from the CLI, you can also do Snyk monitor, which is actually going to add that project into your Snyk organization and then monitor it on a regular basis. So once a project's actually imported into Snyk, it's not only tested on first import, it's tested every configurable time period. So you're picking up changes there all of the time. And I think we can also do Snyk code test here, which is going to do the Snyk code magic, and it's going to find those issues in our homegrown code. And then the Snyk container CLI, I can test things directly from my Docker hub, or I can test things that are running in my local Docker. So we do something like Snyk container test. Is going to go off and go to Docker Hub and look at that image in my Docker Hub repository. It's going to take a little minute to run that one. But you can also do all the container scanning stuff directly in the Docker CLI. So there's new Docker scan commands that are directly in Docker, and that's basically using Snyk on the back end. So you can do, you know, all the security scanning stuff without leaving the Docker CLI. So that's the kind of super high level, I think. I mean, it'd be cool to have some discussion. I know I've run a little bit over here.
Oh, it's totally fine. I'm like taking notes on all the things I want to try out now. So thanks for the details. I was wondering, so like checking a Docker container, checking the container files before they are actually being deployed. If I have like a current deployment of a Kubernetes cluster, how would I be using Snyk if I don't have access to anything before that? So I'm like maybe taking over a system and there was no CI/CD.
Okay, so you're saying no CI/CD, you've just got your own Kubernetes cluster that,
for example, yeah, just I would.
What would that workflow look like? So the Kubernetes plugin for Snyk it sits inside the Kubernetes cluster, and what it's doing is going to scan any new container images that are being spawned in your cluster. And does it give you the ability to? Does it scan everything that's already running? No, I think you can, for stuff that's already running before it's installed, you can then choose when you go into your add project, it'll show you everything that's running in your cluster, and you can just tick box. I haven't got a Kubernetes cluster with it running in at the minute, but you could just tick which images, which container images you want to scan that are running in your cluster, and then it will also automatically pick up new images that are being deployed. I mean, typically for a workload like that, for a workflow like that, I guess the best pattern would be that when you're developing your container image, that you're scanning it at that point before you've deployed it for a start. So, you know, I mean, if I am building a Docker image, you know, whether I use Docker scan or whether I use Snyk, when it's in my local Docker before I've put it anywhere, you know, scanning it there is the kind of recommended best way. But, you know, almost everybody now has the option to do container image scanning in your registry as well, right? And I mean, you know, whether that's Snyk or not, you know, the best practice for everybody really would be also to turn on whatever image scanning your container, your registry of choice has, turn it on, right? I mean, Snyk are integrated into Docker Hub, so you get free scans in Docker Hub anyway from Snyk. But you know, that's the
it's like I'm looking from the monitoring inventory side, like if you cannot migrate everything to the best like Devsecops lifecycle, but you want to introduce Snyk in your current system and you have some whatever CI/CD tooling and you don't really have control over it. But if you get inventory like of the Kubernetes cluster or maybe like a different cluster system, and then you have like the possibility to say, hey, I want to scan this and this and this. I think this is a great, great
yeah, and
possibility.
that's exactly what the Snyk operator for Kubernetes does. It'll give you that ability to go in there and pick images that are running in that Kubernetes cluster and have them scanned on a regular basis.
That's great. I'm a little overwhelmed, to be honest, but if are there like from the others in the session, please, questions, thoughts, or are you trying it out now directly?
I have a question. So I'm really curious about how the priority store is calculated. So
yeah, so
that
yeah, let's just go back to that, and I can we can just make sure everybody knows what we're talking about. So we're talking about like if I was to go here, right? So these scores here. Yeah, so every CVE will have a standard CVSS score, right? And CVSS is a standard scoring mechanism for how serious a vulnerability is. It's based on a whole range of different things. Can we actually look at one here? Yeah, so it's based on a kind of built up out of all of these different things from the calculator, like, you know, how complex an attack would need to be, you know, what the vectors are, et cetera. So, you know, I mean, a physical attack vector is probably less serious, for example, than a network attack vector, because it's less likely that somebody's going to have physical access to the machine. But they're sort of built up out of all of these different things. But what the Snyk database does is enrich that with particularly with this stuff about is there a mature exploit available for it, and is there a fix available? Because, you know, again, with this worldview that we're really about empowering developers to fix things, we want to be able to have things that are actionable. So having a fix available really makes, you know, it should push something right to the top of your priority list because it's easy to fix. You know, so that becomes a fairly key part of the scoring for how they're prioritized in the Snyk UI.
Okay, cool. Thanks for that. Probably when someone else has not a question, I have also another question. Probably
I would have two questions. One would be regarding the Terraform feature, which, if I understood correctly, is still in beta. I tested it out on the Snyk dashboard, that you have some kind, like, integrate your GitHub repository, you have some kind of Terraform code, and then you will receive some kind of information. Like in my case, I had one regarding having a SQL database with public IP, which is like an understandable information. Is the information for the Snyk command line interface like is a similar scope of checks that it provide or will be doing? Like what is exactly is the command line checking for the Terraform?
Yeah, so the rule set's identical. You're going to get exactly the same results back from the CLI as you will from the GitHub repository. One of the big things that's changed recently is that when you scan Terraform from the CLI, the scan happens locally, because one of the problems was that, especially in big organizations, you can have folks who have thousands and thousands of Terraform files. And so sending them all, that's okay when you're connected to the Git repository, but sending them all from the CLI could take forever. So that's one of the things that's become a lot faster recently, but they use exactly the same rule set. So it all uses Rego in the back end that comes from Open Policy Agent. So it's a set of it's a kind of rules-based language. The rule sets are massively growing at the minute. I have to admit, I'm not completely up to speed with all of the things that it's detecting. I know we had several hundred every month at the minute. I know one of the other things that's really exciting for me that I haven't tried out yet is that we have just done where we scan the plan output and not the static files, because in practice, obviously, a lot of people are going to be doing things like interpolating variables and things at instantiation time. And so that makes IAC scanning quite tricky in a sense, right? Because if you haven't got variables in there, how do you ever know whether it's insecure or not? So you can only do that once the Terraform plan has been built. And I know that IAC does support or is about to support that. I think it's in beta, that feature, but again, things are moving so quickly on the IAC front, I slightly lose track. Did that answer your question?
Yes, exactly. Thank you. The second question would be, I'm really admiring the features for the VSCode plugin. Is there a way to mute the output? On your example, you had a lot of highlighting for your code that there's something false or alarming, and a lot of noises.
Yeah, there probably is. I have to admit, I would not describe myself as a programmer. I'm a systems architect. So, and B, I am old, and so I'm not used to using VSCode. You know, my normal programming environment is Vi, so I am sure there are lots of configuration options, and I can certainly find out for you if that's something that's of interest. So ping me afterwards, and I can find out. But yeah, I know we're working quite heavily on the VSCode plugins at the minute, particularly the Snyk code and the Snyk OSS stuff. But the Snyk code stuff's super cool for me, because it's so fast compared to what SAS scanning, you know, that kind of scanning used to be, where they used to take, you'd run that stuff overnight because it took so long and it would throw up loads of false positives and things, whereas it's fast enough to work on real time. So it's pretty cool, and I really like all the where it'll show you those examples from other open source projects who fix the exact same problem that it's just found in your code.
Very cool. Probably then I have also another question. So is it also possible to get the bill of materials? So as example, I have a simple application, and for compliance reasons, my security officer comes to me and says, okay, I have now developed the application, and you need also to provide all the licenses that you are currently using, or probably also stopping me so that I'm not allowed to use some of the licenses in the company.
Yeah, I should have mentioned that as well, that one of the key features of the Snyk stuff is about license compliance. So for every single one of those open source packages that's being picked up in the scans, you also get all of the licenses, and it's configurable, which, you know, you can say, well, I don't want, you know, X license to be allowed, but all of these ones that are permissive are all fine. And yeah, that's my fault entirely, that I get too excited about the code base stuff and I forget compliance people like the license bit.
Yeah, no worries about that. I was only asking for that, so because it's mostly some part of my work that I need to handle these compliance stuff.
One of the other things that I did want to show you that we've kind of which I guess falls into that space that around compliance and things, is that there's been a lot of talk recently about this supply chain security stuff, right? Typo squatting and all these things where, you know, stuff's getting into open source projects, or people are releasing things that have names that are similar to other things to poison the package repository. And so we built this thing called Advisor, which we've just kind of been bringing out. This is entirely free kind of tool. And what Advisor allows you to do at the minute across 3 ecosystems is to search for packages. You can kind of think of it like booking.com for open source packages, right? So say if I want, like, you know, let's go to Python, and, you know, if I do like requests. So Advisor combines the security information for that particular package with the community data for like how healthy that ecosystem is, to form this overall score for like why you might want to choose this particular package. So, you know, it's going to show you how many times is this thing downloaded, how often is it committed to, how big is the contribution community around it, does it have contributing documentation, code of conduct, and are there, you know, big security issues in that project. And so it really gives you this thing that's never really existed before, which is a way of being able to decide whether you should use X package or Y package without actually just going and, you know, randomly looking at source code. So we're going to build lots more ecosystems into Advisor. So it kind of gives you this window of how do I choose which open source package to use. And that's a hard problem for a lot of people, right? I mean, I've been around open source software for, you know, 25 plus years, and, you know, how do you ever find out what the best things are to use? It's really only from being around things for a long time. But the more and more people start using open source software, the kind of harder those choices are. Like, what should I use, you know, for doing HTTP in Python? I mean, this is a fairly obvious one, because I think requests is pretty much the standard there. But there are, in other ecosystems, particularly like in Node and in Java, there can be lots and lots of packages that do basically the same thing. So how do you decide which one to use, right? What factors should you use? And you know, it's quite surprising often that people don't perhaps understand that the community health of that project is equally as important as what it does, because, you know, what's going to happen in a year's time when you've based your application on this thing that had one person developing it who's now disappeared or infected your code with some remote backdoor. So yeah, so Advisor's really cool. I'm trying to talk a bit more about that at conferences and things. So
do you probably know when Advisor will support Drawling? And also probably because I really love the Rust person, I really also want to know if it's also support Rust. in future.
So I know they are on the roadmap. So Go support in Snyk generally is yeah, I think we do support Go now. Go's obviously a little bit more difficult because it's a compiled language. So, you know, Go and C and things like that are much more complex for any vulnerability dependency thing, right? Because you don't have like a package.json or anything. So, you know, we have to get into like sort of reading the headers from the Go binaries and stuff to work out what modules have been included. I know the development team did a lot of quite cool work about sort of disassembling the Go binary to find out which modules had been in it. But cool. We definitely we support Go from the source code management side, you know, where obviously you've got your modules defined and stuff at that stage. I think Rust is super cool, but like it's one of those things when you said the development team are like going 100 miles an hour because we've got so many ecosystems that we want to cover, and like it tends to be the ones that are sort of less interesting, but they've got more developers in them that end up first in the queue. So it's like .NET and PHP, which is like, really, there's still people writing stuff in PHP, but there's millions of people writing stuff in PHP.
I better don't say that we use PHP at work. So
there you go. Who knew? Yeah,
I mean, I was wondering if so. I have the advisor website open now, and I really love what you're doing because I think this solves like a decade of problems of mine, like finding the right package, and maybe the license is not compatible or security issues. The thing is, can I automate that? So does it have a REST API which I can interact with?
So it does not at the minute, but I do think that's a super interesting idea. So I'm going to go back to Oren, who runs the advisor project. I'm going to say that we should have a REST API because I can imagine that people might, like, I can imagine, for example, a CLI tool. Is that where you were going with this? It's going to do a quick, like...
Yeah, the thing is, oftentimes, maybe I have an idea and I'm like a user on the CLI, as you mentioned, or maybe I'm using the IDE. I'm looking for building integrations. And sometimes I'm saying, okay, this could be something as a suggestion, like what to use. But I want to build it myself. So potentially we want to build something in GitLab and integrate with Snyk. This could be a potential idea, but also like you're running CI/CD and you're using curl or whatever, like a Python implementation to query something. I want to automate things, and I was just talking to Kenny Johnston in our Slack, and I said, manual work is a bug for me. I'm automating everything. So I want to have like a consumable REST API and really REST and not like SOAP or whatever, so that I can like check and throw something at it. And I think it doesn't need to be super complex and super over-engineered. It should just be like, I want to search for something and I get a JSON result which I can pass, which could be the first, the minimal viable change or the first iteration of it.
No, I think that's a great idea.
So not pushing hard on that. It's just like if you have a web front end, add a REST API to it, and maybe some examples to how to interact using curl or maybe Python, whatever you're confident in, and ask not only me but also other developers or other users who like regularly need to evaluate which package to use, because in my experience, you're sitting in front of the screen and then you're like checking this PHP package or this like C++ project or something else, and like, should I be using that? Okay, the license works. I have no idea about the security because there is no history about this. And if like having that puts out a huge effort. And I could also imagine that it helps your thought leadership and messaging in a way of saying, hey, we're doing something good for open source.
Yeah, no, I like it. I like it. our whole focus, over the next year or so is APIs around all of our services. The kind of I think where we see ourselves going is moving towards being a cloud native security platform, where we do start to have all these things in that. So I definitely think that would be an interesting thing for Advisor. I'm excited about that. So I will speak to the folks who are developing Advisor, and I'll let you know.
Yeah, and if it makes sense, just connect us and we have a coffee chat and do it in a separate session.
I mean, at the end of the day, all of these the Advisor pages are all programmatically generated anyway, right? So
yeah, so it's the developer in me who has built a REST API in the past decade, and I'm like, yeah, if I have a web frontend with HTML, you probably have a data provider in the backend somehow. And if it's like GraphQL, okay, but potentially you have something is already there which scrapes the data and provides it to you. Because I'm also like thinking of, because we talked about this before, how we can like integrate Snyk and GitLab, for instance, and like use what's already there. And I've just seen like you providing the pull request, so we can actually also do the same for a merge request. I'm not sure if it's already there, but we should like kick off alliances and partnerships probably. Yeah. What else can we try? Is there a sort of thinking of like what GitLab security scanning uses? Is there something like secrets detection in there as well? I would guess so, right?
Yeah. So in the IAC scanning, there is obviously secrets inside things like Terraform and Kubernetes YAML and that kind of stuff. I mean, secrets detection in general is quite a hard thing to do, because you've got so many potential patterns that things could be, whether is it a secret or not, right? Unless it's in a setting that defines itself as a secret. But yeah, we're doing a lot of work around that at the minute.
So this might be a question you might not be able to answer, but are you using any open source scanners in your product, or how is the engine being built? Like, because I think for secret scanning we're using, I have no idea, I need to look it up myself. It's an open source scan engine which has certain patterns predefined. So
yeah, I'm not sure what
particular
technology that team is using for that.
Okay. But yeah, I know where you're coming from. Like detecting an AWS key is probably easy, but detecting specific credentials which could look like a MySQL root password is like, you need to.
It could be anything.
Yeah, you need to learn from mistakes, or you need to learn and adopt and have something which is like shared amongst everyone. So yeah. Interesting. Since you mentioned like machine learning for the suggestions, how is this built, or what is how huge is the backend being designed?
So this Snyk code is based on a technology from a company we acquired called Deepcode, and Deepcode have a very large backend database of open source code. From I can't remember the exact size, but it's large.
Okay, yeah, this was basically my question, because when it comes to machine learning and other things, I'm like learning myself, and GitLab acquired Unreview for machine learning and code suggestions, and I believe this goes into like the same direction with having data available and training the models and doing more stuff in that direction to make it like
and we just acquired a company called FOSS-ID. Have you come across them before, where they look for snippets of open source code that might have been included accidentally in your own application, i.e. someone's copied and pasted stuff from another project. And that's a similar kind of problem space, very large databases and fast pattern matching across huge amounts of back end.
Yeah, this kind of reminds me of my studies where they didn't have any robots to check whether we copy pasted the source code from a colleague or not to pass the exam. But yeah, I know it's a huge problem if you copy a gist from GitHub or from GitLab or from anywhere else, and there is no license and no copyright assigned. Am I legally allowed to edit to my code base? No, I'm not. But how to detect that? So during review as a maintainer, you should be aware of it, but like when you're starting with things, you're not. And
yeah, I mean, I think
sometimes
without a license, the default in GitHub, and I assume the default in GitLab as well, is non-permissive, right? It's copyright.
Yeah, it's like your private copyright sounds odd, but you're not allowed to like match it with GPL or Apache or something else. So you need to reach out to the author and ask if they can add a permissive license. And sometimes this works. So I remember like having a shell script for, I think it was for notifications, something in Bash, and I'm not really keen on Bash programming. But there was no license on that code snippet. And if you can reach the author and make it happen, it's good. But on the other side, detecting that and keeping companies' code safe from any legal actions potentially, I think is one of the things. The other one is like checking if the licenses are compatible with, so like license scanning in a sense of, is there any HEPL inside because it's not compatible with GPL or Apache, and this is currently potentially a problem with many projects shifting away from Apache and installing something which is more, I don't know, more safe. But yeah, it's generally a little bit less permissive then. And this puts companies and environments at risk, and preventing that is a good idea. Any more questions, thoughts, wishes to try something out live? Do you have a repository which is broken? I potentially have one.
I think GitLab is not supported at Snyk at the moment.
Yeah, no, it is supported.
Okay.
I've never actually used it, so.
But not on the free tier, could be, right?
Possibly not on the free tier. No.
Okay.
But I'm not. Don't quote me on that. I'm not sure why.
Probably we need to talk a little more about that. I think you probably have a trial version which you can like extend for, which you can use for a limited amount of time or a limited amount of projects.
So Snyk has a whole free tier. So there are some features that are paid tiers only, but the free tier, almost all of the things that we looked at in demos today are available on the free tier. The only limit is around the number of scans you can do within a time period. In general, is normally how things. Our whole kind of go to market is really about that freemium. You can have almost all the features for free forever, but if you need to do things on a more regular basis, much larger scan volumes or whatever, then obviously you need to have a paid account.
Okay, yeah, I need to check it out. I have an old webcast repository where I was doing a CI security webcast, and this holds some vulnerable code. I'm just not so super fast with clicking around in the Snyk interface. but I really like the integration with Google as an SSO provider, which is super convenient.
Folks, I'm afraid I'm going to have to go. I've got a call from the US that I have to be on now. So thank you all for.
So we extended the session a little bit. I was like missing time. Thanks for the great session and the great insights. I will share a blog post with all the insights later on. And yeah, other than that, I would encourage everyone to try out Snyk and all the integrations into CI/CD, Docker, Kubernetes, and stuff. And say bye-bye on YouTube. And